In the last few videos, we've looked at what happens after you put things into the blue bin, but we know there's lots of reasons that things don't get into the blue bins. There might not be a collection program, you might not know how to sort things properly. There's all sorts of barriers to diverting materials in this way. In the next few videos, we're going to look at what are some alternative ways to recover materials outside getting the consumer to do source separation themselves. And this is especially relevant to our IC&I waste. So as I've mentioned before, the IC&I sector is the largest waste contributor and the one with the poorest diversion rates. In Ontario, that's regulated separately from our residential waste. So it's a sector that some of these technologies might be able to apply to beneficially if we want to get the circular economy kickstarted in the next few years. So our issue with waste, as I've highlighted before, is our waste production keeps going up and up and up and up and up. Although we do have better diversion now, our total landfill rates are similar just because all our diversion gains are kind of taken up by our waste production gains. So these alternative technologies are really targeting this portion that is just like, it's like the principal on your mortgage. We're kind of paying off the interest here, and we really need to actually start digging into this base load to get somewhere. So that's what some of these technologies might do. And the three that we'll talk about are mixed waste processing, also called a dirty MRF. So very similar to what we just saw for our source separator recycling, but a little bit different because we're anticipating much higher contamination. Mechanical biological treatment, which is going to be couple what we looked at in the chapter on organic waste treatment with everything we're going to cover with our mixed waste processing. So how can we put those two processes together to both make the MRF work better and also recover the organic fraction at the same time as we're recovering the recyclables? And then lastly, our last resort is landfill mining, getting that stuff out of the ground once it's already made it through the system and put in the ground, but we are still interested in recovering some of that material. So we'll start with mixed waste processing. So mixed waste processing was first introduced in the 70s, but the real interest at that time was to extract high energy content of the waste to use in incineration plants. And this waste that's been pre-treated to select the best fuels is called refuse-derived fuel, or RDF. You can incinerate mixed waste directly, but if you do a bit of pre-treatment, you can really improve the energy content of it. So that's what RDF is. That was kind of the original intention. So there's an energy enhancement side as well as a diversion side to the motivation for mixed waste processing. And the whole formula that makes mixed waste processing work is our total diversion of material is going to be equal to our participation rate times the process recovery rate. So in our Blue Box program, participation is limited by a number of factors. In our mixed waste process, we can basically make participation 100%. So whether that's the only system you have or a more effective system would be have a diversion system and then apply mixed waste to only the residual. As long as we're sending that whole stream through something, we're really going to maximize what we can recover. So even if our mixed waste processing isn't going to be as effective as our Blue Box program, as a complement, on the whole, we're going to divert a lot more material. And we've had source separation programs stall out at certain percentages across North America. So on the whole, we're only getting 25 to 35% diversion by relying on these. So that other huge chunk of material that's just going through the system, a lot of it from the IC&I sector, the promise with mixed waste processing is we'll start digging into that majority of material. So on the whole, this is kind of what our mass balance looks like. We've got our mixed waste coming in. We'll initially sort things into two size fractions. The small fraction tends to be residual material or organic material, and then the large fraction tends to be our containers. So if you think about what's in your garbage, the little pieces of dust and food scraps and the junk out of your vacuum cleaner is going to be in that small fraction. The large fraction is going to be those big pieces, those containers, those boxes and things like that. So that large fraction will be further processed and either produce recyclables, which will go into all the processes we covered in our last video, or into RDF, which is more suited for thermal treatment. And it's always best to see it in action. So I'll link you to this video. This is a facility in Cyprus that's treating mixed waste. And as you watch it, you'll see many of the same equipment that we saw in the previous video for the Tulsa MRF facility. You'll just see, as you can see in the screenshot here, there's a lot more contamination on the incoming material because we have that huge fraction from the mixed waste versus just the contamination that was accidentally put in the blue bin. So you'll see how there's a few different things about the process to handle that, but overall, really using the same principles. I'll give you a couple more examples of facilities using mixed waste processing. This is one called the Infinitus Renewable Energy Park in Montgomery, Alabama. It's closed now. While it was open, it had mixed waste coming in the door. Then it applied a few separation technologies that we've seen already. So a trommel to do that large and small size split. The large fraction would be our recyclable and RDF material. So to split those up, they used a drum separator. So that was one of those air classifiers to separate the light stuff that's hard to recycle, like film plastics, from the other materials. And then those other materials that could be recycled went through a disc screen and an optical sorter, as we've seen, to separate those out. And those were sent off to recycling. Then we've got our RDF fraction would be sent off to an incinerator. And then the fine fraction would be sent off to a digester and used for fuels. So they're trying to find the best use for all of these different streams. And this facility claimed an 85% recovery of the recyclables coming in the door. Here's one more example. This is in Skedsmokorset, Norway. This is the first fully automated mixed waste processing plant. And you'll see in the equipment list, there's all sorts of items that we've seen already. They're using 16 optical sorters. These are really expensive equipment, but they're trying to replace work that people are really good at, looking at materials and removing them. And one thing that's interesting about the approach with this facility is they actually ask people to bag their organic waste in a special green bag and put it in with their other waste. So when it gets to the facility, they'll use an optical sorter to find all the green bags and pull them off. And then everything that's left will go through further processing to divide it out. Mixed waste processing facilities have decent recovery rates. If you think about how difficult the job they have set out for themselves in, their performance is pretty good, better on some materials than others. In this table, you can see recovery of films is pretty low, so these are pretty difficult materials to deal with. But things like metals, 90 to 95%, that's a really valuable fraction, but those are relatively easy to separate using magnet and eddy current separators. And then things like PET and HDPE, which are most valuable fractions, are up to 90% as well. So we can really do pretty decent with these technologies.